It is my hope that today's presentation will indicate and show the ease of use of working with Inventor in the woodworking area. There are many approaches to building millwork, doors, windows, furniture. Today's environment will be what we call solid body modeling with the additional tools that we've developed called skeletal modeling through a tool called skeletal dress up. It is our hope that once you review how this can be used, you can see the benefit. So I'll get started by first creating my first brand new part. Now, I work in what is called starter parts. A lot of time, starter parts allow me the ability to quickly generate information. And because many of the things that we do in this area is somewhat rectilinear, this is a very good place to start, we feel. And obviously, this in conjunction with other standards allow us a lot of flexibility. So we'll get started with what I call a starter part. And the major difference between a starter part and a standard Inventor part is that those parts will actually be available with a dialog box. So if I was going to build, let's say, a base cabinet, and again, I'm just picking simple things today as first in our 2018 series, and we'll say that the base cabinet will be 60 inches in its width, and the height, we'll say it's a sort of a standard kitchen cabinet, 34.5 inches with an 1.5 inch top, and the depth is 24 inches. You can see by typing in information just in this dialog box, it's actually building the bounding box for us. And of course, if something changes, you can see that I can just type this in and it changes, hopefully standardizing the way we do things. So if there's more than one engineer, one designer in our company, we've developed a methodology, a workflow that I think we can live with. Now you'll also see there's other fields in here like material thickness, which I haven't assigned yet, but I will. And obviously we can add more and more to this. This is called iLogic menus, and iLogic of course is built right in. So everything that I'm showing you here is available through the URLs that I posted at the beginning of our presentation. These all can be downloaded and utilized. They have libraries that come with it. And I think if you follow what I'm going to do today with that, I think you can get reasonable results. Now, once this is built, okay, just as, this rectangular cubic shape, I might want to put a kick on it. So I'll sketch on the face of this, and I'll draw a simple rectangle that will actually simulate the kick. And then using the dimension tool, I'll dimension the height of the kick. And I could put just 4 inches there if I wanted to. I can say 4 inches. But I prefer to use a variable like kick K height equals 4. And if I do that, that will allow me to exercise that later on very, very easily for change. And then using the extrude tool, I'm going to extrude that and cut, and I can say kick depth equals 3. So again, 2 items that I've just added. Again, nothing dramatic, but I now want to put those variables in my menu. So if I go into Manage, I go into iLogic Browser, you could see that in the browser I have a form called Dimension. I'll right click and pick Edit, and over here you'll see some variables. The original variables I started with were a part of my template. My template had length, width, and M thick already assigned that just I associated when I started building. Now, just just the last minute or two, I put kick height and kick depth in there also. It wasn't there when we started. Of course, it could be any naming convention you want, just as long as there's no space or dash, because dash would think it would be minus something. So I'm going to right click on it, pick edit. I don't see them here, but I'll come up to the top and I'll say I want to see all my variables, and there's the kick height and kick depth, and I just drag them over, pick OK, and then you can see that they're here. So if I wanted to change the kick height from 4 inches to 8 inches for whatever reason, you could see that it's changing also. Other thing that's happening in this particular model is that if you were zoomed out, or if you were to the edge of the drawing, if you change a value, it zooms right back in for you. So again, it's saving time. And as I indicated earlier, everything that's in my presentation is available at no cost. So all of these tool sets that I'm using today, if anybody's interested in them, please just get back in touch with us on that. So going from here, my next step is to take this and turn this into individual solid bodies. Because right now, if we take a look at the left-hand side of the page, okay, you'll see that there is only one solid called solid 3. That's what this is. Obviously, I've been in and out of this a little bit. If I hadn't, this would have been solid 1, but these all can be renamed. Our next step is to actually create 5 or 6 different panels or solids that make up this cabinet. At this point, the next step would be to move into what I call my skeleton dress-up. At the top of the screen, you'll see something called skeleton dress-up. This was added if you downloaded the Woodworking for Inventor tool set. And this tool set that is available has saved many of our clients over 30-40% of their time just doing strictly base solid modeling. So it's my hope again to show you why people are interested in its usage. The first thing I'll do is do what is called a dress up. And it says select the body that you want to work with, which is this. I pick it. And then it's asking you what faces or what face do you want to work on. So I'll say select all faces. Once I do that, what it's about to do is it's going to create individual panels of every single face. It will also make the thickness of each of those panels 1 inch, unless I tell it otherwise. So what I'm going to do is I'm going to come over here and say, no, I want to list the parameter, and the parameter I want to use is a parameter called M thick, which equals this one here, which doesn't do anything at the moment, but will once we're complete. So it's going to give me a dialog that I'll be able to change, so I can change the thickness of the material to 0.72 or 19 mil, or whatever it actually measures out in stock. Okay. Now the next thing it's going to ask you for is which direction are the panels going to grow in. So if you take a look at this cone here, each panel has a cone on it. The top, the left, the right, the back, the bottom, and so on. If I click on the cone, it is now showing you that the right panel is going to add 3/4 of an inch to the overall dimension of the 60-inch cabinet. Well, I don't want that. I want it to go the opposite way. But you can see you can go either way on any of these panels. Holding the shift key down, I can touch the face and I can remove it. So in other words, right now, the front of the cabinet will not have any thickness applied to it, so it'll be an opening. I'll rotate the model so I see the bottom of it, and I'm going to hold the shift key and touch the bottom. I'm going to rotate it again and rotate to the back side. Hold the shift key and touch the back. Now the reason why I'm touching the back And removing it at the moment is because the back is 3/8 of an inch thick, not 3/4 of an inch thick. So I do not want to use that variable M thick on the back. So I have two buttons. Check means I'm done, finished. Plus means I have more to do, but I want to execute the command at the moment. So I hit the plus sign, and you can see all the panels have been generated, 3/4 of an inch. And now I can touch the back. I see the direction that the arrow's going in, and I can type in 0.375 and hit the plus, and then OK. So what I've just done here is I've now created a solid, multiple solid bodies. You can see here on the left-hand side the names of them. So the first solid was solid 3, which I showed earlier. The left side, or that's the bottom panel, is solid 3, panel 1, solid 3, panel 2, which really don't have much of a meaning, but we're going to name them. Before I name them, I want to turn off the original solid because that is sort of the baseline. That's how we built it. So there's two ways of doing it. You can go up to Visibility, Skeleton, Hide. And what it did is it hid the skeleton. Now notice it just turned off solid 3. If I right-click on solid 3 right now and said turn the visibility on, then it comes back on. Or you can come up here and say skeleton, hide, and show. Again, just a quick way of doing it. There's no right or wrong. It's, lots of different approaches. Now, what I normally do at this point is I start naming my parts, okay, or my solid bodies, because each of these items will have to be cut, either on a table saw, panel saw, router, any number of different tools. So I'm going to click on the first one, and that's going to be bottom. Click on the second one, just click it twice, just like a Windows in the Windows file system, and that's going to be kick. Next one, right panel. You can also right click on these and go to properties, and this is going to be top panel. This is going to be left, and this is going to be back. Okay, so I've named them all. I'm also going to pick save my work, and I'm going to call this, let's call base unit presentation 1. Okay, so at this level, we're now ready to move forward. Looking at our model now, we see that we have 6 separate parts, or 6 separate solids, I should say, with the original skeletal body. And when looking at the model, we see that there are quite a number of inconsistencies where the panels actually intersect other panels. So similar to utilizing 2D systems like AutoCAD, we've come up with a trim tool that will allow us to trim or miter those intersections. Obviously, once they're trimmed or mitered, then we can start thinking about joinery, whether it's dowels or biscuits or mortise and tenon joints or conformat screws or knockdown fittings. We'll be going into all of that in later presentations on the simplest and easiest methods to accomplish that. But the first thing that I want to do is take a look at the bottom of the cabinet itself. So the bottom of the cabinet is, of course, not complete. It just has that front sort of lip on it. And what my goal now is to take what's there and extend it to the back. So utilizing standard tools, I'm going to say I want to sketch. I can just hover over the back side and allow me to select the back face without rotating. Once I've done that, I can pick extrude, and the arrow off of the long grain shows up, and I want to go and extrude to the back panel itself. If I put a dimension, I'm locking it down, okay, to whatever the size is. If I say go 2, then the depth variable here can then be adjusted, and it should work. So if we change the 24 to 32, you could see that that's adjusting because I said extruded 2. But looking at this, it still seems odd because there are a lot of things that are not right. All those intersections, the back is intersecting, all those things start happening, and that's where we start considering trim tools. So in skeleton dress up, we have a trim tool. If I pick trim, it asks me what do I want to trim, and I'm going to trim the back. And trim to what? Trim to the top, the left, the bottom, and the right, and hit the plus sign because there's going to be more. So by doing that, we've trimmed the back up. And now what I'm going to do is trim up the top and the bottom face and to the sides. And you can see that it's starting to look real good, okay? The next thing is the kick. Looking at the kick, what do I want to trim? I want to trim this side and this side against the kick and pick OK. So now what you see here is a pretty accurate cabinet that's already almost completed with all the parts. And of course it is fully adjustable. So as we've done before, if I change the kick height from 4 inches to 6 inches, you could see that the bottom shelf or the bottom panel is being dealt with. And if I change the kick depth from 3 inches to 1 inch, everything is adjusting accordingly. So that's why we use the iLogic tool set here to be able to accomplish many of the things that we're doing. Now, I usually save often, just good practice. The next step is I want to create dados, stop dados, for this back panel. And you could see that the back panel is butt to it, but it doesn't go beyond the sides. We take a look at it, you can see that where it is, and if I go into wireframe, you can see the wireframe is accurate. Okay, but again, it's not what I want. So the next thing I'm going to do is I want to create dados and stop dados for the back, and I want to push the back in 7/8 of an inch so I could put a cleat on it and hang it on the wall, or at least mount it to the wall. So the first thing I'm going to do is go to the back panel in the solid body area of the browser. Because there are now names, it's easy to find. I'm going to right click on it and I'm going to say hide all the others. So by you just right clicking, you could hide everything else. The next thing I'm going to do is sketch on this panel and offset it, offset the edge, let's say 3/8 of an inch, because that'll be the depth of the dado, or whatever your dado depth might be, which is what I just did. And then I'll extrude just the outside edge, the thickness of the material, 0.375, and pick OK. So now this back panel is 3/8 of an inch longer along the length and 3/8 of an inch, well, really 3/4 longer and 3/4 wider. If I go back to the browser, right click on back, and I now say show all, it all turns on, including the original skeleton, which of course I said we can turn off. And you can see that that skeleton, of course, is now intersecting other things that are here. We also see that because I added 3/8 of an inch, it's going beyond the bottom. So what I'm going to do here is go ahead and say thicken or offset this bottom face 3/8 of an inch, 0.375, and I'm going to remove material. So you can see that's now taken care of. The next thing I want to do is take this entire panel and move it in 7/8 of an inch. So using direct editing, we're in 3D model, direct editing, I'm going to move not a face, but a solid. I touch it. I'm going to grab the head of the arrow pointing in the direction I want to move it in and push. And you can see that I'm pushing a solid body along that axis. And I said minus 7/8 of an inch. And I'm going to hit OK. So now what do I have is 3 edges are intersecting the cabinet, and the bottom is, of course, going through the cabinet. So again, all I'm going to do at this point is go back to my trimming tools, skeleton dress up, trim. What am I trimming? Left side, bottom, right, and top against the back, and pick OK. Now, let's look and see what just happened. Taking a look at this now, flipping it over, and right-clicking on back and turning its visibility off, you could see that what's happened here is that these are dead on. If we turn off the top panel, you can see it's a blind dado. And of course, we can define clearances as a need be based on whatever CAM tools you might be using. So again, very simple, straightforward, and it's fully configurable. Now, the next thing is, it wasn't absolutely necessary for me to cut that 3/8 inch off the bottom, because maybe the back won't go all the way to the bottom. It'll go to the bottom of the surface that's here. So the direct editing tool, completely your control. If I say direct edit, and I say not a solid, but I say face instead, so I can move solids or I can move faces. And if I move my mouse onto a face like I'm doing there, I can take the head of the arrow, as you can see, and I'm actually increasing or decreasing the size of that. But I'm going to say snap to, because I'm not sure what the measurement is, snap to that edge and pick OK. So that's why it wasn't absolutely necessary for me to cut off that 3/8 of an inch, because I knew I could do that later on. Okay, so let's spin it around a little more and we'll take a look at that. So everything here looks pretty good. Okay, and of course, if we want to change the depth of any of these items, you can see that full control over everything here. At this point, I think I would like to put a vertical divider into this unit. So the vertical divider sort of matches these panels, these side panels, but they are slightly different because I won't have a kick. It'll just be straight connected. So what we have come up with is a tool called cloning. So if we clone this panel, it's prompting us what is the distance from the original panel to the new panel. And if I type in whatever I'd like, okay, you can see that it's moving in that direction. I can also change direction by tool sets that we have here. Now, it's going to move 17 inches or whatever I tell it, and the thickness of the panel could be whatever I tell it, but I've opted to use material thickness, so that if I change material thickness in my iLogic tool set, it'll change it everywhere. So I hit the plus sign and it actually created it for me. Now, it's not where I want it. I think I want it centered. So how do I center it so that if I change the width of the unit, it'll stay centered? Well, again, not too difficult. We'll just create a work plane. We'll find the midpoint. So now we have a midpoint on that plane. So if I change the width, of course, that'll stay centered there. And then using direct edit again, I'm going to move this particular unit, but I have to move it from the center of this clone to this actual center of this work plane. So that's where we say locate. And I'm going to locate the center, which is what I just did. It found it automatically. I can grab the head of the arrow and move it now anywhere I want, but I want to say snap to. Instead, I want to snap to that plane and pick OK. Okay, so again, locate. I can move it, right? Snap to here. OK. And you can see that's done. If we turn off the work plane, you can see that it still needs to be trimmed. So let's trim it up. Trim. What am I trimming? This against the back and the top. And then I'm trimming this against the bottom. Now looking at what I did here, this model that I've just been working on is maybe about 5 minutes worth of work. And it's fully parametric. Let's check it. 48 inches. The height is 22. That's a little short. Let's make it 34 again, 34 and a half. Let's make the depth 12 inches. Let's make the material thickness not 0.75, 0.5, that's 625. Everything just adjusted. Let's make it 1 inch. So that allows for change in materials that come into the shop, where if you needed, if everything was based on 3/4 and it came in at 0.72 or 0.73 or 0.74, one adjustment here would make sure that all your joinery fits right. And that's why what I like doing about, including that, because it doesn't take really too much time whatsoever to accomplish that. So we're ready to move on to our next steps. Rectilinear cabinets are, a mainstay in many of the clients that we work with. But again, the goal is to, yes, be able to accomplish them, but any other custom work that you could ever imagine. And of course, done as quickly as possible and constructed the way you would want them to be constructed. So what I'd like to do with this particular unit here is put some curved open shelves attached to both sides of this particular unit. So to accomplish that, probably the easiest approach would be to sketch on the top surface. Let's take a look at the top surface. Let's draw a simple rectangle starting from here to there. Let's make sure that the tops are collinear to each other. So that they will stay where they're supposed to. And let's dimension this. And whether I want it to be the same depth as the rectilinear cabinet or a unique one, that's up to me. So in this particular case, I'm going to say I would like it to be depth, which would be the 24 inch. And I'll also dimension this and say this dimension equals that dimension. Okay, so you can see that what I've done here is I've created a dimensional value so that if I change the depth of my cabinet to 24 inches, okay, then this will change and this will change. And if I wanted a true radius, okay, not an elliptical type of cabinet, this would work just fine. I'll create an arc, okay, and the arc will start here, it'll go to here, And as you move your arc, you'll see there's a tangent symbol that just appeared. Wait for the tangent symbol, and now there's your perfect arc. Extrude this. Obviously, you can say height, or you can say extrude to, and let's pick the bottom of the kick. New solid, very important, and pick OK. So now what I have is a brand new curved cabinet, okay? Well, it's not done yet, okay? And it's a big block or a big chunk. So let's put a kick on it. Well, maybe not. No, let's put a kick on it. So I'm going to sketch on the bottom surface and offset that inward and dimension it. And also now say it's the kick depth. And if we use the same variable names, parameter names over and over again, this becomes just a language that's very, very easy to control. And everybody within the company or the engineering department knows it, so that they can go right to the different areas of construction. I'm going to extend that and that. So I extended both. So I should have a closed loop here. And then if I extrude this and say I want to cut, and I want to cut to the bottom of the unit, you could see that what I've just done now is created a pretty accurate model. Now for testing, I'm going to change the depth. I'm going to go from 24 to 20. Works great. Go back to 24. Turn it around, you could see that right now the back is flush. Okay. Can it be set in? Sure it could. Could it be like similar to this? Yes, it can. No different whatsoever. Okay. Oh, I did forget one more thing. I needed to put a cleat in here, okay? We'll come back and grab... No, we'll do it now. Let's sketch on here. Let's just draw a simple rectangle. Let's dimension it. Let's say we use a 4-inch cleat. And then without even dimensioning it, you just can say that this line matches up to this line matches up to that, and this line matches up, of course, to this edge. So that's pretty straightforward. And extrude this. And what do I want to say? I want to list the parameter and pick material thickness. And it's a new solid, and I pick OK. And then finally, I want to cut a 45-degree angle, so I just touch this bottom edge and chamfer it. And chamfer it again to material thickness, okay? So that by doing this, everything just adjusts perfectly to your parameters. So let me rotate this around, turn off the shading, so you can see what just happened here. So you can see that, you know, I got a 7/8 inch clearance here. This is at 3/4 of an inch. Obviously, I could have butted everything together, but I just gave myself an 1/8 of an inch clearance, and everything else is pretty adjustable right now and very accurate, I believe. Okay, so going forward, let's take this now and actually turn it into an open shelf. As we've done before, we'll go to Skeleton Dress Up, pick Dress Up, and touch it. Okay, select all faces. Okay, and the only face I want to remove, okay, is going to be this bottom one. This is going to be material thickness as my option. Okay, everything else looks pretty good. Hit the plus sign and done. Now let's check out what happened here, okay? Let's turn off, of course, some of these options that we had here, solid 13. If we went here to skeleton, show or hide them all, we can do the same thing. Select all skeletons and hide. and they're hidden. Well, we've got a couple things we have to still do here, okay? The first thing is, let's look at this. Let's trim some stuff up while we're here. So, trimming, okay, which way do I want to go along? I'm going to trim this to that. So you can see that this looks good here. Next, I'm going to trim this to here and here. So that looks good also. Okay, top. Let's trim the top to here and here. Everything looks pretty good here. Okay, let's clean this up and finish it up, okay? So I'll pick Save, and let's flip it over and clean up the bottom. So I'm going to sketch on the bottom what I just did, and I'm going to project this edge, and I think I'm just going to draw a line between the end point here and there. If I've done everything right, I should be able to extrude what's necessary here. If there's any kind of break, which you can see there was here, and now I extrude this, okay, it doesn't come across the front. I had gone to the front incorrectly. But again, very forgiving. I'm going to flip it the other way. It's called material thickness, and I pick OK. So that's complete. Let's flip it. Nope. No, we have to do the kick. Okay, so you can see that I'm missing the kick in this particular situation. Okay, so what I'm going to do here is, again, sketch on here. I'll do an offset of this, like so. I'm going to dimension the value, which is kick depth. And then I'm going to extend, okay, the tool here, tool there. And if I extrude this now, you can see that that looks like it's going to work. But we're going to offset this one more time. Okay. And that dimension here is material thickness. And then I can extrude just that. Obviously, slight problem, and that's because they're not closed. So let's go ahead and just take one to here and close it from here to there. If those are closed, I now should be able to just touch this and extrude it to, no, it should be kick height. Distance should be kick height, or it could have been that way too. Both of them would work, but it's a new solid, and I pick OK. Looking at what I just did here, you could see that this all looks very accurate. And I'm going to put one more, I'll put one shelf in here. So again, under skeleton dress up, clone. I'm going to clone that piece. Well, let's put it at 12 inches above. Material thickness, yes, that looks good. Hit the plus sign, and it's done. Save my work, And last step would be I want to mirror this whole panel over to the left-hand side. So let's turn on the work plane that I created some time ago, and then pick mirror. I want to mirror, don't want to mirror features, I want to mirror solids. And when I'm done, I'll have new solids. So I'll pick 1, 2, 3, 4, 5, and 6 about this plane here, and pick OK. I'll turn off the visibility of that work plane, or I could leave it on. Maybe I'll need a center brace, not sure, but I definitely can see it. Let's pick save, and let's test it. So if I now say the internal width is 24 inches, that's done. That's complete, okay? If I say the height is 28 inches, and if I say depth of cabinet is 18 inches, good. If I say the kick height is 6 inches, if I say the kick depth is 4 inches, this cabinet is fully contained, fully controllable. And my hope is that what I've shown you up to this point is a method that you might consider. Let's change the thickness. Let's say the thickness was a 0.625. Everything just adjusted also. Or 19 millimeters, okay? Let's say it's 19 mil, because you can just type in mm, and now it's 19 millimeters. And I save my work. After reviewing the model, this might be satisfactory for just a quick presentation, but to go a little further, I'm looking at the vertical panel in the center of the rectilinear part of the cabinet, and I'm thinking that that should be a blind dado. So to correct that at this point, late into the model, it's fairly simple. The first thing is I'm going to go over to the browser, find the solid body and the name, and I'm going to say hide others. And then what I might do is I'm going to create a work plane right in the center of this, and then go ahead and just add some material. So what I'm going to do here is just add just a bit of material. Oh, let's say my blind dado, I want it 1.5 inches back from the front, okay? And this is going to be 0.375. So I just added 3/8 of an inch. Now I'll mirror that about that plane and say okay. So now we've accomplished that. And I'll then go back to the browser and say show all, which of course turned on the skeletal models, which of course I can turn off or on multiple ways. And then what I'll do here is I'll trim. So what I want to trim? I want to trim the top and the bottom about that and pick OK. Let's go ahead and turn off the center vertical and see what just happened. So there you have just an incredibly easy way to start building. Just turn it back on, I pick save, and if I want to turn off the work plane that I had just created, I'll turn that visibility off and pick save. So there should be no stopping one from easily developing techniques and methods even after the fact and when you think things are almost complete. I'll pick save, save my work, and we're ready to move on. Looking at my model, I think I'm going to make a couple more decisions. I'm looking at the vertical divider within the cabinet, the original cabinet we built. And I think what I'd like to do is actually create a blind dado into the top and bottom pieces with the least amount of trouble. So in a situation like that, again, this becomes really quite simple. The first thing is I would go to the browser and I'd find the panel that I want to work on, which I just did, center vertical. Right click on it and hide others. And then go ahead and sketch on the top surface. And maybe now create the tenon that I'm considering. Dimension it. Let's say I want 1.5 inches off the face and extrude it. And let's say I want 3/8 of an inch. Okay, so that's going to be the actual tenon that will create the mortise. Now I want it on the other side also, so the simplest way to do that is to mirror. So I'll create a work plane, find the midpoint, and then mirror it about that plane and pick OK. Okay, very good. Now, at this point, I really don't need the actual work plane on anymore. So if I want to, I can turn that visibility off. Go up to the browser, right click on center vertical, and you can say show all. If you want to turn those skeletons off, pick skeleton, select all, and hide. Very good. And then finally, trim. What do I want to trim? I want to trim the top and the bottom against the vertical and pick OK. Let's check it out by turning the center vertical off in the browser. That's what I'm doing right now. Turn the visibility off, and you can see that that's an absolutely perfect blind dado associated with what we just did. Let's turn it back on. Okay, and then pick save. At this point, to me, we're pretty much finished to a certain degree with what I call my initial engineering. I have my concept down. I know approximately what I want. I could create working drawings from this to get approval. Maybe I have to go a little further. Maybe this isn't far enough, but it all depends upon the job and the client that you're working with. But of course, we're missing lots of stuff, okay? Obviously, I don't have any really joinery here except a couple of the dados that I put in to show you that we could do it. I don't have shelf pins, I don't have dowels, I don't have conformat screws, I don't have pocket screws, I don't have mortise and tenon joints, I don't have biscuits, I don't have lamellos, I don't have drawer slides, I don't have drawers, I don't have doors. And in fact, I don't even have materials assigned. I have no edge banding. I don't know what the grain direction is. So I can keep going. But for the most part, this is okay to maybe get an approval. Obviously, at this stage, if there has to be a change, it's real simple to change. I think you've seen that as I'm working through this. That is what solid body modeling allows us to do fairly quickly and easily, plus so much more. So where do we do all this other stuff? Okay, let's say that it has been approved and we need to go further. So the next thing might be, okay, taking this into what is called an assembly. That means all the solid body parts that you see here on the left-hand side of the screen can be turned into parts, full parts that could be machined. Go directly out to CNC. If you have CAM tools, or go out to drawings so that they can be cut on a table saw, or go out to output to a panel saw, go out to a spreadsheet so a panel saw with an optimizer can read that information in and automatically create the necessary code for it to machine correctly. You can also see that, the coloration here isn't too exciting. But again, it's conceptual more than anything else. But it's accurate. It's very, very accurate. So the next step in our process is to now turn these into individual parts. And the way it's done is by using the Manage tool. And there's something called Make Components. And what this tool will do is it'll turn solid bodies into parts. The way it's done is I can touch each of the individual parts if I want, pick it, it highlights it, but that would take too long. I can highlight it in the browser, hold the Shift key, and go to the bottom of the list, and you can see it's grabbed all of these. Now, the other thing it's going to do, it's going to ask you where do you want to put them. Okay, in other words, when it's done, it's going to create all these parts, and it's going to ask you what folder do you want to put it in. So here you would tell it the folder. And then here, it's going to ask you what is the name of the assembly, and it's going to use the name, same name, prefix of the part. So this is called Base Unit Presentation 1 IPT, and this file is going to be called Base Unit Presentation 1 IAM for assembly model. I pick Next, and you could see here that the solid bodies, these are the names of the solid bodies, will then become part names that are the same. So that's what it's going to do automatically. Now, if there is a part that already has that name, for example, bottom, I must have another file with bottom on it, it's adding a number after it. Same thing with kick, same thing with left, same thing with back, because those files already exist, and it's not going to override them. What it's going to do is create new, but give you a numbering scheme after it. So I pick OK, and then we take a look at it, and you could see here we now have those files that are generated, and these are all individual part files. If I pick Save, what it's now doing is it's saving all those individual files, and I'll pick OK. So now, at this level, each of these parts, each of these are separate parts. So if I touch this curve, for example, right-click and open it, that curve is a separate part. And every one of these files is controllable and adjustable. And I'll pick Save, so save my work. For our session this afternoon, one of the most important features of using Inventor and Woodworking for Inventor and some of the other tools that I've shown is its ability to pull information directly out of Inventor such that the engineering group had done. Things like cut listing and bill of material is very, very important for other people within the organization. If we could minimize the time that it takes from design to ordering, or order just enough and not over order, our profit on a per job basis can go up considerably. So right now we have all these parts done, and we should be able to pull information out of this Inventor model so that we can reuse it in some fashion. So in our tool set, when we're in an assembly, we have something called Woodwork Design, and the first box on the left-hand side is our material box, where we can assign material, we can assign grain or change grain, we can do things like workpiece oversize. So sometimes you will have a finish size and an oversize, rough size, finish size. And all of this can be associated directly to the model. Now, because it's Inventor and because it's fully customizable, everything that I'm showing you can be adjusted for your individual usage. And again, the tool sets that we have been able to distribute, through the URLs, will be able to accomplish the tasks I'm showing you today. So if I pick the Assign button, there's two buttons here. One is called Assign, the other one is called Edit Materials, okay? We're not going to edit any materials today. We're going to just assign materials. And when you assign materials, materials can come into different categories. Solids, which are hardwoods and softwoods. Boards, which are items that you purchase. Panels, like 4x, 5x. A laminated board is a panel that is already sided on two sides. Multi-layer boards are boards that are build-ups. Could have multiple cores, multiple veneers. It could have sound deadening in it. It could be something you buy or something you build. Because if you do, say, a build-up board, you want to know each of the different materials that are made up in the build-up. And some of those could be oversized and some of them could be final size. Obviously, if you're doing a build-up, you want to cut your mica possibly or your veneers oversized before you trim them, and this will tell you both. Desktops, that's running length of material, rods and molding, and of course veneers, edge banding, paints, and lacquers. Wouldn't it be nice to know how much lacquer you need to be able to do a job based on a coverage of whatever you determine? So when we talk about any of these, there's also different calculations that are being addressed. For example, solids, when you pick something that's a solid, it's going to calculate board footage. Whereas if you pick boards, it's going to calculate square footage. So these are kinds of things that are neat about working in this system. So if I pick solids, you can see that there's a host of different materials and material names that you can associate to any of your parts. All of this is adjustable. Material, the way material looks, adjustable, of course, also. The naming conventions can match MRP systems. All of this is able to be altered and changed. If we go into boards, okay, you can see like walnut plywood, rift oak, 13 ply, and so on. So these are just categories that we can work with. So if I say I want everything here to be rift oak, it's 13 ply, and I pick apply, because I haven't touched anything, everything here will be rift oak, 13 ply, and that's already done. Now, notice what has happened here. What's happened here is the grain direction is always going to be based, firstly, on the longest side. So the panels, the vertical panels all look good. The horizontal panels all look good. The kicks all look good. But these corners here, these radius corners, chances are this side is longer than that side. Or if they're exact, it's not sure what to do, because you could see some problems. So if that happens, you can say grain. You can touch what you want to change, and then touch on a length that you want it to go in. So I touch this, and it should be along or parallel to that side. This parallel to that side. Okay, and this parallel to that side. So if you have something that is equal, yeah, there could be a chance that it's not going to work the way you want. But you can see here that it did everything that it was supposed to do quite accurately. And it looks pretty good. Now, if you also say that the bottom, these base units, okay, are not going to be rift oak, but they're going to be plywood, and I touch 1, 2, 3, touch all three of them, and hit apply, then they'll turn into plywood, not rift oak. And, 'cause, 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 ' as you can see what just happened here, and maybe they'll be covered with something, okay? And I'll pick save, and I'll save my work. Now, if I go to bill of material right now, I will get a listing of every single part. As you can see, the length, the width, the thickness of every single part that's here. And that's what it's doing. If you take a look at the back, there's your 3/8 of an inch. If I go down to, let's say, the center vertical and click on it, you could see that it says it's rift oak, it's plywood, and this is how many square feet of that material. So in other words, all of this is automatically being generated for you. If I go out to Excel with this and save my work, then I'll get a report, and that report can move into all different types of areas, okay? This one report is going out to a product called Cutright for a panel saw, and this will control a panel saw immediately. If we didn't want it to control a panel saw and we just wanted it to go to, say, a user who does the ordering, then we can change the actual presentation, okay, of the template we're going to use. And we can have multiple templates based on the type of reports that we want to generate. And again, as I said, all of this you can test on your own. So if we take a look at what I just did here, okay, you could see here that here's the complete parts list, okay? Here's the name of all the parts, the material code, material name, quantity, length, width, and thickness. In fact, if we had sheet metal parts, we would have the gauge of the sheet metal there also. Going further, I can get a material summary. So the material summary is telling you how much rift oak, that's 3/4 of an inch, how much plywood, that's 3/4 of an inch, how much rift oak, that is 3/8 of an inch. And what it did here, you know, why does it say it's a 4-inch thickness? The reason why there's a 4-inch thickness is what happens when we look at these radius panels here. These radius panels here, what it tries to do is square them up. Okay, so when we look at any of those panels, you can see the radius right kick, okay, it's trying to square it up. You know, so that's why that's happening. Now, if we say that, let's just, for example, assign solids. Let's say walnut, rift walnut, okay? Or let's do bird's eye maple. Let's say this panel, and that panel were bird's eye maple. It's kind of neat. You get real good quality images immediately, okay? In fact, we can go further with this and get much better quality, as you can see. So I've got these back panels that are bird's eye maple, and I'm going to take the shelves and I'll say they're pine. Let's just say, no, let's say they're rift oak. They're fine. We'll make them rift oak. So this is bird's eye, that's rift oak. If we now go ahead and look at our BOM, okay, let's look at one of these items, okay, back panel, radius left, okay. Here's maple, bird's eye, and this is board footage. So what this is doing is it actually is saying board feet if you're solids, square feet if your panels. If we go out to Excel with this, of course, now because I've selected something that was bird's eye, the material changes and my report changes. As you'll see in future seminars, all our hardware will be specified there also. So take a look at what we did here, and we're pretty good to go. We don't want the shadows. We can take shadows off. And the quality of our imagery looks pretty good. In fact, we can do things that are kind of interesting. We can make things in glass. Okay, so if you have a door that you will add glass to, okay, you can actually show it. So what's happening here is that you're getting tremendous visuals as well as high quality documentation. Now, there's a glass with a blind dado. Maybe not the best, but we pick save. And save our work.